So, Rick Crosslin, I'm a teacher in Wayne Township Schools, but I love science. Been teaching a long time, and I joined CEFI about 25-30 years ago as a board member, and it's just another way to reach families and kids with science. We do the science fair, and we do CSI, Celebrate Science Indiana. What I love about this, it's an opportunity for families to see behind the scenes about science. It's like, you know, going to a science convention, but you're not a scientist. You're just a regular person learning about science. So,
my name's Keith Ramsey, and I've been working for Wayne Township as a teacher for 23 years. I really wanted to be a part of Celebrate Science Indiana just to support science education for children. I'm the STEM department chair at my school, and I love science. If you had a chance to come to CSI, God bless you, and we hope to see you next year.
Thank you.
That's it. My name's Keith Ramsey. I also teach for Wayne Township, and I love pyrotechnics. And today we're going to show you some amazing experiments.
So our first show is all about fire and flames. And one of the most famous fires and flames happened a long time ago is something called
the Hindenburg disaster. It was 1937 on May 6th. Germany made an airship that was filled with hydrogen gas. It looks like the Goodyear blimp that's filled with helium, but the Hindenburg was filled with hydrogen. And on May 6th, there was an electrostatic discharge that ignited that hydrogen gas inside the Hindenburg and burned it to the ground. Over 30 people lost their lives. We want to show you the difference between the gases, helium and hydrogen. So in this balloon here, we have helium. In this balloon here, we have carbon dioxide from our lungs that we inflated it with. This balloon here is filled with hydrogen gas, that same gas that was in the Hindenburg. And we're going to slowly ignite these so you can see the difference. So this is a balloon that was just filled with CO2 from our lungs. And this next balloon is filled with helium. The same gas you use with your birthday balloons. Alright? And this last one is filled with hydrogen. So this will be a little louder if you want to plug your ears. A little louder. Ready? Alright. That's why we don't fill the Goodyear blimp with hydrogen. Now, hydrogen gas is not the only flammable gas. I'm also going to show you a demonstration using propanol. This is just a 5-gallon water jug. I'm just going to coat the walls with the... But I want the vapors to stay in the bottle, so I'm going to plug it with this squishy skull. And by rotating the bottle, I'm just increasing its surface area so it vaporizes quickly. One thing that I did special to this bottle is I put a screw in halfway on the neck of the bottle here and halfway on the neck of the bottle here. And I'm going to use a high frequency generator called an Uden coil to jump plasma from one screw to the other. But when that plasma, that spark jumps inside, it will combust the gas that's inside, that propanol. And it'll decompose into carbon dioxide and water. Hopefully our skull will shoot all the way up to the ceiling and you'll hear a pretty loud boom. So here's our Uden coil. Makes a kind of a crackling sound. Right here, I think. Because of the cord.
Put this on it.
A little closer. You get it right there?
How's that?
Yep, that's good. So you want to see the skull shoot up and you'll see that combustion in the combustion chamber. Think of the gallon jug as a combustion chamber. Okay, here we go. Oh, it almost made it to the ceiling. So that propanol, thank you, decomposes.
And one of them is called the flaming hands. And so this one is, this one's kind of scary for us too. So we have our special mixture here. And he's going to get his hands wet. I'm going to get my hands wet. Because if you know about heat, heat and gas likes to go up. And so we're hoping all of the flaming hands goes up. Ready. Okay. So we're making some bubbles with a special fuel. My hands are wet, and hopefully I do this right.
Flaming hands!
Now, if you notice, the flames go up because of convection currents going up. And there's no damage to our hands, thank you, because our hands are wet. And I close it to put out the oxygen that's on there in 1, 2, 3. That's a flaming hands.
I'm going to also put on my gloves for this because this can get a little hot. And in the test tube, I have what's called potassium chlorate. And through thermal decomposition, I'm going to melt that down. That's the oxidizer. And it's going to consume the sugar in the gummy bear.
Now, there was no bears hurt or damaged during this demonstration. The bears are fine. The gummy bears are not, but the regular bears are. And so that's a solid, and he's going to melt at every element, every chemical, and make sure that when you leave, you take a periodic table. So every element, everything has certain properties. And so there's a melting point and a boiling point. He's getting this very hot, it's starting to melt, and we're going to see what happens when he puts the sugar bear or the gummy bear in there. But make sure you take some of these home with you. How we doing?
Almost there.
Poor gummy bears. There we go, it's starting to melt. It's got to the melting point, the MP, and you can see it went from a solid white to a clear liquid. So it's pretty hot right now, but there's no flames yet.
All right, just the gummy bear. That's all we're adding. Here we go. He's screaming out. You can't hear him because his lips are gummed shut. Oh, the poor gummy bear. Oh, he sacrificed himself for science.
Now, what was the smoke coming off? Was there a carbon on that? Ready? I hate this part. Did you hear that? But did you see all the heat that came off of it? Oh, I need a volunteer. Thanks for volunteering. It takes courage. Yes, you volunteer. Come here. You volunteer. You sure? Okay. Pick somebody for me. You want to volunteer? Okay, come here. Most of the volunteers don't get hurt. Go on. All right, hold this at the top like that. And so, hold it straight out like that. Okay. Let's see what happens when I bring these two together. You'll be able to hear the sound energy and show that to everybody. What do you see there? Smell it for me. What does it smell like? Like burnt something. In fact, it's filled with holes. And so this is, you guys ever heard of E equals MC squared? Yes. Energy, mass, heavy, speed of light. And so we're seeing some energy transfer. Let's give it a round of applause. Thanks for your help. Now you can keep that. Now that was a chemical change. It's a chemical change. So now we're going to get a chemical reaction with, this will be as hot as the sun for 1 microsecond. I got to remember not to hit my thumb. Ready? Whoa! That was cool. You see that? You see that? As long as I don't get too close to you, you'll be all right. But if I start getting really close, that's the... That's the problem, no. Don't worry. No, this is too dangerous for me to be this close to you. So, let's see, I need a volunteer. All right, come here. Whatever you do, don't hurt me, okay? All right, so glancing blow. You know what that means? Not like that, okay? Kind of heavy. There you go. Why are you shaking? Stop shaking, man. All right. Don't hold it tight.
This might be the day,
It might be the day he dies. You have insurance? Neither do I. Okay. Glancing.
He's scared.
Come on, man. Harder.
Let me do it.
Ready? I hate this part. Ready? Go, let go. There we go. Let's give him a round of applause. You okay? All right. Those are the cannonballs, and you can get energy through a lot of different ways, but you cannot create it or destroy it. You can only transfer it. Everybody say that with me. You cannot create it. You cannot destroy it. You can only... No, you do the talking on this one. All right, he goes.
Okay, what are pickles soaked in? Yes, vinegar, and this one says with sea salt. So if you soak a cucumber in vinegar and salt water long enough, that salt permeates the cucumber. Now what do you think will happen if we run high voltage through a cucumber that has salt in it? Let's find out.
Ready?
Yep.
So, I've turned that on there, and you see anything happening yet? Is it smoking?
Okay, wait for it.
It's dripping. It's smoking.
Keep watching.
I hope it doesn't explode.
There it is. That yellow light is generated by the sodium ions. They're getting so excited, their electrons go to an outer energy level, and when they return, they emit photons. Those are single particles of light. They appear yellow because of their wavelength of around 400 nanometers. That's what the color of sodium looks like when it has that charged electricity flowing through it.
And you guys remember sodium lights in parking lots? When they came on, what color were they? Yellow at first. So there you go. I don't know if Thomas Edison tried this. Go ahead and turn that off. How about a round of applause for that one? Good. That's a good one. Okay. All right. You're up.
Now, well, sodium emits that yellow light. This first one has neon inside of it. So I'm not going to touch it. I'm just going to get close, and you'll see the wavelength that neon gas creates. You see that? Now I'm going to get close enough for it to actually transmit plasma. Can you see the plasma?
That's that little blue spark.
Right. Now, it's kind of purple. That's because most of the air inside this room is 70% nitrogen. So nitrogen emits more of a purple wavelength. That's the shortest wavelength through the light spectrum that we can see, the color purple. It's about 300 nanometers in length. The color red, though, that's the longest wavelength that we can see through the light spectrum of about 700 nanometers per photon that you see inside this ampule. This is what nitrogen looks like. Again, this has a very short wavelength, about 300 nanometers. It's the color purple, just like the discharge that you see coming off the toroid. Now there's another thing that I love to use my Udin coil for. This is to transmit electricity into my skull cannon. And this is what it looks like. I have a 5-gallon water jug, and I like to put it just to this screw. It's going to make a spark inside the neck, and that's going to combust all that propanol vapor inside. And that energy is going to expand, that thermal expansion is going to launch the skull high, maybe as high as the ceiling if we're lucky. Are you ready?
Not yet. What he means to say is he's going to blow that up. Cover your ears.
And 3, 2, 1, here we go. Oh! Now, when propanol decomposes, it creates carbon dioxide in which it leaves water. This is just water that's coming out of it. That's like a pretzel.
Don't touch that piece until like 1 minute. And it actually has lost all of its rubber properties.
It shatters. Yeah.
And shatters. It's pretty cold. This one's not too bad. Catch that one. There you go. All right, so hey, we got both of we have put a cap on it. It's going to expand. It's going to finally. What do you think the plastic's going to do? Everybody take one step forward. No, backwards. Take a step backwards. Here we go. Ready? Are you ready, Keith? All right, so thanks for coming. After the show, please don't touch any of this stuff. It doesn't belong to us. Here we go. Ready? I'm going to cap it, and he's going to. All right. Don't walk them that way, okay? So I added water to it. So what do you think it's going to do to the water? Okay.
Exploded.
No, hopefully not. Let's see. Take that off. That's always good. And this.
Whoa.
So that's actually the water condensating off of that. Stay back. And pretty cool stuff, huh?
Get your bag over here.
So you hear that clicking, that's the water freezing. And look, as you can see, it's still got nitrogen, but most of the water is frozen. Too cool, huh?
Hey, how you doing?
And look, the water that's spread out is turning to ice. Let me try one. This is extra special. Each of you owe me $30. This is my payment. Thank you. Hey, thanks guys for coming. See, and it will boil around, but you don't want it to. You want it to keep dancing. See how it's dancing right there? You don't want it to land.
It's so cold.
It's boiling. My hand is so warm compared to that.
That is so cool.
Yeah.
What if you?
Yeah, it'll be even more now. I'll tell you what. You guys want to blow into this a little bit? I bet you do.
Oh yeah, let's blow into it.
Okay. Don't drink it.
Okay.
And line up, blow down, blow into it. All right, next, one at a time, blow straight down, blow down.
Come on.
There you go. Blow. There you go. Your blower's a little crooked. There you go. Good one. Good one. Let this little young lady here do it. Very nice. It won't hurt you. You're going, ah.
Have a turn.
Yes, one turn.
Have a turn, please.
Very good.
Have a turn.
Yes.
You want to
Train. Very good. You want to try again. You want to move away from it. It won't hurt you. Your lips will turn blue and then purple for 3 days. It'll be a nice look for you. Go on, try again.